The harder ionic compounds form when a transition metal cation bonds with a nonmetal anion. Transition metals are located in the D block of the periodic table, and most of them have more than one transition state, or possible charge on their ion. The noted exceptions are listed here. Notice aluminum is part of the list. These are the rare exceptions I was referring to earlier. These metals follow the group 1 or 2 path on the flow chart. Therefore, you do not need to use a Roman numeral. So here we go. Follow the game plan. Ask yourself, is the first element a metal or nonmetal? Let's look at our periodic table and find Cu. So we see that Cu is on the left of the table in the D block. Cu is a transition metal. Now follow that path on your flow chart. Now we see that we have to determine the charge on the metal using the anion. Chlorine is in group 7, so it will form an ion with a -1 charge. If chlorine is -1 and you have only one chlorine atom in the formula, then the copper ion must be +1. So we know that the first part of the name will be copper 1. Continue to follow the flow chart to finish the name. The next question we have to ask ourselves is the anion a nonmetal or a polyatomic ion? Cl is a nonmetal. So when we follow that path, we see that all we have to do is use the IDE ending, changing the ending of chlorine to chloride, and we have the correct name, copper 1 chloride. Pause the video and try the rest of the examples. B and C will flow through the chart, and D and E will simply be given to you. Let's get the formula for titanium 4 sulfide. Follow the game plan. Is titanium a metal or nonmetal? Titanium is right here on the periodic table, so we know it is a metal. It is also a transition metal, so we can follow that path on our flow chart. All we need is the symbol of the metal, Ti. Now we have to figure out what sulfide is. An IDE ending tells us that sulfide comes from the element sulfur. Once again, an ATE or an ITE ending would tell us we are dealing with a polyatomic ion. So we have to use the charges on the ions to figure out the final formula for the compound. Sulfur is in group 6, so it will form an ion with a -2 charge. The Roman numeral tells us the transition state of our transition metal, Ti, 4+ in this case. Remember, you can cross the charges to help you determine the subscripts. So finally, we determine that the formula for titanium sulfide is Ti2S4, right? Wrong. You must reduce the subscripts if they can be reduced. Or think of it this way. It takes 2 sulfur ions with a charge of -2 to balance the +4 charge on the titanium ion. The correct formula is TiS2.